There we go. All right.
Hey.
What was wrong?
For some reason, when I switched up the accounts, it changed the stream key.
Oh, okay.
So I would have been logged into Julio's everything, and he's not here to do that. And that's why it went so smoothly every other week, because Julio was here.
Okay. No worries. We're learning.
We're here.
Oh.
We are here, guys.
All right. Good morning, everyone. Sorry, we had a few technical issues this morning. We're trying to execute with new staff this morning, so we're learning some of the secrets that we didn't know about before. So we're back now. So this morning, I'm Brian Walsh, and here with me today is Dustin Saunders.
Good morning.
And let me talk a little bit about Exerceo real quick. So Exerceo's mission is to lead and inspire others to transform society by extending relevant learning and mentorship into everyday lifestyle. Ultimately, what that means for everybody here is our goal is to help you successfully enter the workforce and rise within the workforce, and that's what the working groups do. We do also have other content up on Exerceo. We have the Rising Professional Challenge Series, the Rising Leadership Challenge Series. I would encourage you guys to check those out as you enter your profession and start to rise within your profession as well. Those are auxiliary content meant to augment the working groups, not replace them. And with us this morning is Pat Garvey running the tech stuff. He has been graciously helping us with all of our social media. I don't know all the proper terms, but please like, share, and do all that good social media stuff to push us forward on each of those channels. He has been graciously working hard to improve our social media presence, so I can't thank him enough for all of his hard work. He's been pushing that today on us. So I really appreciate all his help with that. So,
I should mention really quickly, your camera is frozen.
oh, my camera's frozen?
Yes.
All right, so apparently my camera's
Oh,
frozen.
they can hear you.
Is it working now? No. Huh, okay. All right, so they'll work on fixing my camera so you can see one lovely frozen shot of me for the moment. We'll figure that out. It's one of the many problems we're having this morning. It's one of those mornings, but it is life. We will move on. We will post the attendance shortly, I assume. So when the attendance is posted, we'll let you know, and we'll get you guys to sign in so we can get you that lovely email with all of the notes from today. All right, so the topics we're going to go over today are core software development and revision control. All right, so we're going to jump into that. So with core software development, one of the things that we've added more recently is time zones and software and dealing with time. As you get into dealing with time, unfortunately, all of us think about time in the current time zone we are in and lose relativity. And the other thing that happens with time zones that's kind of odd is when you start debugging things, if you're debugging them across time zones, it becomes very easy to quickly forget that and get led astray looking for something at 3 p.m. Eastern time when it's, in Central time and, an hour off in your logs, and you can be lost trying to find the wrong problem or going down the wrong rabbit hole very quickly. And so one of the practices that we typically do in software is from a software standpoint, we store all times in UTC. Doesn't mean you display them in UTC, but you can display them in whatever time zone the user's in, but you store them in UTC, so it makes it easy for traceability, easy to compare, especially for log messages. Put all of your log messages in UTC so that when you want to find something, you might have to do some conversion, but then all of a sudden your logs are all on the same time zone. You're not trying to figure it out. And, well, this server is logging in Eastern time, server 3 is logging in Mountain time, and then server 4 is on the West Coast, so it's West Coast time. Can you imagine trying to figure out my server and the logs? So unless you really hate yourself, I'm sure you've dealt with this, Dustin.
Literally this past week, we had an issue with our where we have 5 different application development servers that are deployed, and the logging we use.
Looks like my camera's fixed.
Yep.
we use the elk stack for logging and, doing our monitoring. And the time zones were not the same once they got to elk. It was very interesting as you're sitting there troubleshooting, looking at the logs of the application and seeing one time zone, and then looking at and trying to debug the problem from the application monitoring perspective, and they're in a different time zone. So when you get a bunch of logs into the system, it starts to slow down a bit. So doing queries in the system is, quite slow. So anytime that you have to go and change your time zones or change your time ranges, when you're trying to, debug a problem, it can take upwards of 10 minutes just for it to run the query.
Well, and then if you don't trust what the information you're getting in the logs, like what good are they?
Yeah.
The logs are our developer insight into things. And now if it's like, well, if the times are all wrong, you don't know. Like you're all of a sudden you're like, what stack trace am I debugging?
Mm-hmm.
Like, you're just, it's useless at some point. And then that's incredibly frustrating.
Yeah, especially because, and then the other thing that we were running into as well is that, during the time zone that I thought was right, there were other exceptions happening there. So then it's, you're chasing down these other rabbit holes that don't necessarily map to the problem that you're trying to solve. So
no, that never happens.
No, never.
Like daily. So anyway, I mean, we just want to make people aware of time and time zones. Be thoughtful about it, and also don't lose sight into displaying times and time zones with users. They don't want to do things in UTC time, so don't force them to do that. It's all about the experience. So that kind of leads us into talking about logging frameworks.
Mm-hmm.
We're very passionate about logging frameworks. A lot of people prefer the system.out.println or console, or pick your favorite, mechanism to print things to the screen in your favorite language. The problem with taking that approach is now you're compiling this into the code. So you have to compile the code, deploy the code, and run the code to make a change. And then like all developers, right? When it works, what do? We like throw our arms up, we celebrate, right? And it's usually Friday at like 5 p.m. So we run out of the office happy as anything, right?
Yep. Leave it in there.
Yeah, the following week we deploy the code, and operations is like, wow, our logs are filling up with all these random weird messages that don't mean anything to us. And so
they're not coming into the normal log file either.
Yeah, they're going to the console. And then it usually never happens during the day. It's always some weekend, a week later, the hard drive fills up with the logs, and then they ask what's in the logs, and they track it back to
users figure it out.
One of us,
app isn't working anymore.
Yeah,
the logs filled up.
So instead, we want to use logging frameworks, because what they allow us to do is they allow us to go to a configuration file, turn on and off the logging for a specific class or for a specific area. Okay, and that allows us to be methodical about our debugging. The other thing that they do that I really like is that they allow us to add value to the code. So if Dustin here adds some debug in, it can stay in the code. And then somebody that picks up the code and supports the code later, if we put quality log message in there, so make sure you don't just put A or something in there, put, a little readable context so that you understand what the values are printing out, what the context of the code is, so that then when somebody else comes along, there's value in those log statements. So you're increasing the value of the code. Now, it's not perfect, right? What I typically find happens is Dustin will put log statements in, I'll take over his code, and then it'll get me really close, and I'll need some more data. So I'll go in there and I'll modify the log statements, which, that'll have to cause a recompile and everything deploy. But by the third developer, when Pat over here gets to doing it, it's going to be perfect. He's going to be like, oh, wow, this is awesome. We've refined it. We've added value by putting that logging in there. So there's actual value in getting log statements in there.
Yep.
So the other thing that happens with log frameworks is you get all the functionality of the frameworks for free. We don't have to go write our own logging framework. It makes no sense. There's plenty of good ones out there, so please don't go reinventing the wheel. I think from a Java standpoint, SLF4J was a rewrite of the log4j because they learned their lessons and then they reiterated that into a new framework, which is awesome.
Logback and SLF4J become the new standard, I'll say, from any of the log4j fans in the audience here.
Yep.
I was actually just updating the notes this morning as we were talking, realizing that we have some older terminology in here, which, always trying to improve our process here. But the interesting thing with SLF4J is that it becomes a wrapper around the actual logging framework you're using. And it doesn't it only helps us in that we can code kind of the same way across multiple apps as if they're all using that. And logback becomes that implementation of the actual logger. But from a framework perspective, thinking in terms of Java, if we're talking about the Spring framework, they can code directly to SLF or J, and they don't care what the actual implementation of the logging framework is. They can let whoever is building the app figure that out and use whatever framework is already implemented in that application. So if you're maintaining a legacy system that has log4j, SLF4j will just be like, okay, we'll just use that and kind of basically delegate to that framework. And if you're building a newer framework or a newer application, you can use logback and it'll work just the same.
So one of the other things I like about logging frameworks, and I'm kind of famous for this, is a lot of developers use their IDE for debugging.
Mm-hmm.
And that works a lot of times for our smaller projects and stuff like that. But when you get dealing with a lot of these enterprise systems, it's really hard to debug things in an enterprise system. And a lot of times you'll have to debug in production. You can't pause the production website. Hold on, let me pause the website.
Breakpoint.
To, walk through things. All of a sudden, users are calling the help center like it's locked up. I can't check out and buy stuff, right? Think you're going to be a popular person that day? So what happens is if you're using logging to debug problems, you can then go through the logs and start finding this information. And oftentimes, I'm called in to deal with problems that aren't reproducible or they can't figure out easily. So a lot of times what we're doing is we're going in and we're gathering the time of the problem, right? Here goes the UTC thing, right? Oh, the user said, here was the problem, here's the time. So we go look in the logs. We try to figure out what was going on during that time. And then we try to go instrument more debug. And then as the problems are reported, we keep grabbing the logs for that time period and refining our debug and allowing it to happen, because it's not something, most problems aren't reproducible. If you click on this button, this is what happens, right? Those are the best problems to have in life, because once it's reproducible,
I go create an automated test for that too.
Yeah, it's pretty easy to go test, reproduce, and know when you fix it.
Right.
But most problems are like, this user says that this happens when they do this, and you go do it and it doesn't happen. And it doesn't mean it's not a problem. It just means that there's some series of events happening behind the scenes.
Yep.
And it might be a resource not getting closed problem. We'll get to that later. But there's a series of problems that could happen. So a lot of times we're trying to debug problems that aren't reproducible, and logging is incredibly helpful for that. Now, remember, quality log statements, having context and improving the quality log statements. You're going to get that one log statement that's gold, and you're not going to know it because the quality of the log isn't there. Mm-hmm. So make sure you have good quality log statements, but that's where this logging framework helps us. And then once you get into it, you can turn on and off different log levels. Like, oh, I think the problem's here. Let me go turn that logging on in this class in production. So it allows you to drill down, right? And so there's a lot of value in that logging framework. So I would encourage you for school projects, or even as you learn, get in the habit of setting up a logging framework. Dustin alluded to this earlier. We make sure we write it to a file. Don't send it to the console. Write it in the configuration for your logging framework. Make sure it's intentionally set to a file.
Yeah. So I would say there's one caveat to that, being if you are running in a containerized environment, that is the one time that writing to standard out is okay, because there are certain processes in those containerized environments to pick up that standard out and write it somewhere else to a file.
And make sure you are doing that too.
Yeah, and if you don't have that set up, that's even, I was gonna say that's also pertinent to that environment. I was talking about the elk stack earlier. Part of the process that we run is exactly what I just explained, in that we have our app, we have it containerized, we have it running in an environment that allows those logs in standard out to be basically slurped and spit out to that elk stack, and make sure that's in place. And if you're working in an environment and they don't have all that, and they're just, going into each server and opening up log files and just reading and listening to the log files, that's, there are ways to improve that. And we'll talk about that more in our DevOps talk later.
So I'll jump into log levels.
Yes, right. My favorite.
So, so we want to talk about them so that it's kind of educating people. From a developer standpoint, most developers just do log everything to debug, right? Everything's debugged for their standpoint, right? And so, we'll give you some guidelines, and then we'll talk about some, it's not an a la carte thing, right?
A little bit of, error here, a little bit of
it's got to be
here.
intentional. Yeah. So I like to say that, and here's how we use them, and I like to push our implementation on people. because I am biased, but think it makes sense, obviously.
But I mean, we're always open to feedback. So if you guys have, you know, comments or suggestions, let us know so that we can, you know, take that into account too.
Yeah. And so what we try to do is we try to use errors for, you know, if it's a problem that we should drop everything and fix, right? So like the world is on fire, like the application is clearly not working, you know, our customers are not happy, right? And so, and why is this important is what we like to do is we like to scrape our logs and send everything from info above. So there's error, warn, info, debug, and trace. Those are the levels, right, in order. So we like to say scrape everything from info, warn, and error and put it somewhere intentional. And then we like to set up alerts when error logs come in to say, hey, Dustin, error, there's an error. You need to go look at something. There's a fire. Go put the fire out, right? But if we make everything an error, Dustin's going to just get overwhelmed, like on a minute by minute basis. Fire, 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 and he's going to
won't get any work done.
Yeah. Well, and he's going to start ignoring it because he's going to realize that they're not true fires.
Yep. Put it in a folder. Ignore it.
Yep. So it'll be that little like create a rule in Outlook or create a rule in your favorite Gmail, whatever your favorite email rule of choice is, and then you'll ignore it. And then you might as well just stop doing it once you ignore it. So we treat errors that way. Warnings, those are the ones that we kind of say, okay, the app isn't happy. Right? There's a problem. If a user calls, we want to go look at those because this is probably related to something that's going on there, but it's not a fire. Not drop everything, go figure it out. It's the if we have free time, which we never do, right? We'll go fix this, right? Let's be truthful to ourselves. But it's going to be pertinent when somebody calls. You might want to know something about it, but it's not like, you know, it's not something we know is a problem.
Yeah.
Okay. Info is a little harder to find. I like to say we use it. Yeah. Go ahead.
I was going to say, I think info ends up being kind of the grab bag for everything else. If it doesn't fit in one of the other areas, it should go in info. But the problem you run into there is knowing what the difference between knowing what the difference between info and debug is. And that's the harder challenge in my mind. Because error and warn, I think, are pretty standard. Like, you understand, you know, if it's an error, oh gosh. But if it's a warn, if it's an info or debug, that's the harder line to draw in my book. Yeah,
I like to use, we found info is really good for answering questions, like, especially like security errors, like users are denied access for security reasons. We like to make that info because they're going to call in and our support team's going to need to figure something out, right? And then when they say, well, they can look in the logs, oh, Dustin was denied access for this reason, right? Then they have information to make decision, and it's not a bug. They'll just be able to say, hey, look at, you know, you're trying to do something you're not allowed to do. Go speak to your manager. Or the other thing we like to use it for is tracing data, right? Is when a lot of times we're writing systems that move data around. And so we like to give data a unique ID. And that way when someone calls and says, hey, I haven't seen my data, well, what's the ID? Then we can go search in the logs, grab that ID and say, oh, yeah, we saw it. We processed it, and here's what happened, right? So it allows us to have traceability of what's going on in the system so we know if it's healthy. Right. And it allows us to, basically info allows us to answer questions when people are going to call and ask about things. So we want to store it and put things out to info that we need. And that's kind of the way we treat info. It is a little bit of a grab bag. And then debug, obviously, debug is a developer thing, right? We don't use debug in production in theory unless we're trying to truly debug something in production, which should be rare.
The one instance that we've recently run into this with for using debug in production has been when we first released an application to production. So we recently did that on my project where an app that we were given, it was a problem. We figured it out, we fixed it, and got it out into production. But part of the process of us doing that was trying to understand exactly what the app was doing. And we, you know, coordinated with the operations team at the time, made sure that we had enough space for these debug logs as it was very noisy. But we needed that on so that, you know, as we released to production for those first, you know, 3 to 4 weeks, we had that level of information for any time a problem did come in. But once that 4-week period was done, we stopped seeing these issues occurring as we were pushing out patches, fixing things. We were able to kind of take that logging level down a little bit, back to our normal of info, error, and warn.
Make sure you pull it back. I've literally seen. I remember one time we were debugging a problem, and they had turned everything on because they weren't sure what the problem was.
Oh gosh!
And I kid you not, I was like, "Well, just do something intentional so we can see it in the logs," and we weren't seeing it.
Yep.
And then they're questioning what was going on, What it turned out to be is with everything on, our log files were rolling over the 7 gig size every 5 seconds.
Yep.
So literally we were writing out 7 gigs of logs every 5 seconds. And so we weren't seeing our messages because we would try to do something. 10 seconds later, we'd go look and it wasn't there because it had rolled off already.
Yep.
And so if you're generating 7 gigs every 5 seconds, can you imagine how much logs that is? You're going to fill your disk. Now, we have ours automatically rolling off after 8 logs.
8 files.
8 files. So we don't fill the disk. But what was that? 5 times 8, 40 seconds. We have 40 seconds of logging now. That's not useful, right? And these are real world examples, right? I remember the developer when I was working with him on it, I was like, I think the logs are rolling off. Look at the file times. And when we figured that out, he was like, oh my God. Like, it was like one of those things we never thought would happen.
Alex in chat, he said, dear God.
Yeah. I mean, we just didn't think that was even a feasible experience, right? And so that kind of leads into the difference between debug and trace. I like to be intentional about things. And so what we try to say is, debug and trace are developer tools. So I like to make trace those statements that are obnoxious, right? That you don't want to see all the time, but if I'm, if it's in a loop or if it's in one of those functions that's called in a loop a lot, make it trace. And if you can't figure it out, make it one level. And with all these statements, right? Here's the thing, right? If you go into a log and you're debugging a problem and you realize that one of these things isn't true, like you debug an error and it's not truly an error, switch it to a warn. This isn't a one and done thing. Software is a living, breathing animal that we have to nurture over time. We have to fix. If you make a debug that, wow, this is too much information, think of Dustin and say that should be a trace.
Yep.
Right? Well, Dustin's on your shoulder. That's a trace, right? And so go change these log levels, right? And so where I'm going with the log level thing is I used to be able to tell what developer was by what logging they chose. Because one guy on our team would make everything a debug, another guy would make it a trace, another guy would make it an info, and that's not the right solution. I shouldn't be oh, that's a Dustin message, it's an info, right? No. Make a conscious decision to choose the level so that the operations team, in which if you're probably part of operations, you can then start parsing the logs and understanding what's going on and finding information easily because operations can quickly consume all of our fun time developing if we don't make intentional decisions with the logging.
Yep. From a real world perspective too, that same application that we just deployed recently, part of my day-to-day job these days has been adding additional logging to the app so that we know what's going on, especially when we're debugging, complicated problems. I recently just wrote some code that had a good set of trace logs all through it because it was doing looping over the object a couple times that we were, interacting with. And before that, there was no logging. Honestly, there was a system out there. And these are, this is from the part of the previous developers that were on the project.
They didn't add value to the code. They didn't set that in there. So you had to go fix it.
Yep, exactly. So it's been an interesting area of discussion on our team too. Is one of the mantras I've been saying recently is do we add logging to this? Do we have some sort of logs for this? Are we able to actually troubleshoot this in production?
Which you should be telling your team is we have a Saturday class for this.
Yeah, I thought attendance looked really high today.
My team gets so mad at me when I reference the Saturday. We have a Saturday class for that. You should come to it. I'll send them a link.
Yeah.
So be intentional about your logging. Continue to add value to the code, right? And push that value because ultimately, if we want to have fun developing, we need to spend less time on operations and we need to find problems quicker. And that's going to happen if we're intentional with our logging.
Yep. And
we're going to improve that value. And it makes us a better developer. And honestly, most people learn by watching examples. So if you're not doing these things, the people you're mentoring won't do them either. So
I was going to say even your peers.
Yeah.
If you become the example on your team, and it comes up in code reviews, that starts influencing the team around you in a positive manner.
Yeah, I love to be like, oh, you should be more like Dustin. Right.
From a leadership perspective.
Yep.
Yeah.
I love going to the junior developers. I'm like, hey, junior developer Pat over, he's doing a great job. Have you guys seen his log messages?
From a peer perspective too, it's really interesting to be at that level, because if you start impacting that change, especially when it comes to logging, you can say, hey, well, look, in a code review, these are the places where I logged because this helped me debug the problem. And then as you see other code reviews without logging, you can easily put comments in there saying, you could add
code review, fail.
Yeah, exactly. You can mark it needs work. You can say, put logs in these places, and you can see what's going on. It becomes a very easy talking point.
Well, and it gets back to that ideal worker conversation we had, I don't remember, a few weeks ago, but people want to work with people that are similar. And so, as we style these virtues to other people, they'll hopefully do them, and then they'll make the code better for all of us, and all of us will have more time to code. Right. All of us will, get better. But it also takes feedback too. Like, you might during a code review realize that something's a trace or an error that somebody else put a warn because you have more context, and that's fine. Like, don't make it a test. Just tell them, explain to them, I think it's an error because of this, because they might lack some context there that you have. So that's where everybody learns and everybody wins in those situations.
That's a learning point. Yeah, exactly. That's a communication learning point for you as well as whoever you're communicating with. If they don't understand that part of the code, or you don't understand that part of the code, have that conversation.
Ask questions.
Yeah, learn the context of that part of the code, because then that helps spread the knowledge across the team.
Or read the documentation. All right, am I going too far?
Oh man, what documentation?
We know there's no documentation. Come on, yeah, that's the big joke there. So I think we're beating the horse dead there, but I think we've covered most everything here. In the past, there's been some of those wrapper logging frameworks. I've been more of a fan of not using them and using the logging frameworks so that you can get the full features of the logging frameworks, because we've really never switched to logging frameworks. So
the main benefit and we were talking about this earlier a bit, is SLF4J allows frameworks to provide logging in their framework that doesn't, subscribe or prescribe a logging implementation. So that's the big change, is that, some of the wrappers in the past have not been quite as good.
Terrible, yeah.
Whereas like SLF4J, for example, has actually solved the problem in a meaningful way.
Good. All right, so if there's no questions, feel free to throw your questions up there in chat. Pat did post the attendance, so please don't forget to sign in. I usually get 1 or 2 emails afterwards swearing somebody forgot to sign in, so please try to remember to do that. All right, so the next topic is near and dear, exception handling, okay? And this is, we put this in here because we find it's not being taught. We just had somebody, last year came to us and said this was one of their interview questions when they went and interviewed, so they said, yeah, I nailed it. We they had just done the Saturday class right after that. So that was kind of neat. So exception handling and really getting to the finally clause and what that means. A lot of times we try to interact with people on this, but we have to handle it differently through streaming. A lot of people don't understand what the finally clause does. So you have the whole try, catch, and then after the catch, there's a finally. Can we share my screen? I might have to bump the size up. Oh, Lord. Let me check this here. Ooh, let me see.
A little bit. Just a little bit bigger.
That didn't work real well. Let's see if I can put this in Notepad. Oops. All right, sorry.
Yeah, that's good. That's better.
Is that better? That way I can
so.
change things in here too.
Yeah, let us know if we need to bump it up at all.
Yeah, that looks pretty good. It's better. All right. So down here is the finally clause. Okay. So the finally clause does is it ensures that everything within the finally clause is executed, whether or not there is an exception. So if there's an exception, the finally clause gets executed. If there is not an exception, it still gets executed. Okay. And why is this important? So a lot of times when you're doing resource allocation, so see, we're creating a new file stream here. That uses a file pointer from the operating system. Okay. If we do not close that file pointer, what happens over time, and it doesn't happen right away, is there's some limited number of file pointers. Let's say 1,000, right? After 1,000 episodes of this, we come to this code and it says open a new file output stream. So the operating system says, I don't have a file pointer. It says, but I'll wait for one. And so it's waiting for one to free up. I'll let you in on a secret. One is never going to free up. So what essentially happens is it looks like the computer is actually froze. And then imagine this, you restart the computer and everything works again because all the file pointers are freed up at restart. Okay, does that sound familiar? That's a very common thing that people make fun of Windows for, myself included. But what it really comes down to is poor software development where it's not written to close the file streams. And so it just randomly hangs after some number of days. And so I don't know if any of you guys want to write code like that. I don't want to write code like that. Dustin, do you want to write code like that?
I don't want to have to debug that problem.
Correct. That's impossible, right? Just go search for catch and look for no finalies, right?
Yeah.
I will let you in on another secret. Whenever you want to search for something, searching for the absence of something is extremely hard.
Yeah.
Searching for the error is easy. So searching for something without a finally clause, because it'll find all the catches, but then searching for one without a finally is harder.
Yep.
And so the theory here is we open the stream. So a lot of people are going to complain and they're going to say, well, I did this. Let me change this here. They're going to say, they're going to open the output stream like this, right? Bear with me here. I'm going to comment that out. They're going to open the output stream like this. And then they're going to say, I couldn't do that, Brian, because I couldn't run this close statement. Okay. Because when you put the variable name within the try catch, these brackets,
issue.
Yeah, it creates a scope where it's only valid here.
Yep.
So putting this output stream outside of this, assigning it to null, gives it a scope across this whole try catch block. So that's a very important thing to understand.
Yep.
I get a lot of people emailing me say, I tried to do what you said, Brian, it didn't work. So create the scope. So then that makes it valid here. Okay. So now opening the output stream, you can write whatever code you want right above it, below it. If there's an exception, it'll go in, it'll execute the exception, which we're trying to throw the exception to exit here. It'll come down here and now it'll execute this close every time.
Right.
Okay. And so it's very important to understand finally is required. So anything you're doing, it doesn't have to be a file output stream. Anything you're doing, usually anytime you need a close statement, it should be within a finally, because usually close is the standard terminology used for resource allocation. It doesn't mean always, right? But 99% of the time, you want to make sure that you're closing that.
Yeah.
Okay.
Let's say one of the other good examples, and I don't think we have a code example for this in the notes here, but a good example is when we're trying to parse exceptions from like an external call to a different system. Part of the problem that you run into there is you need that finally block, or in some cases you want the finally block because you can have a response that comes back that is executed from whatever framework you're using and actually throws the exception, but the response is still within that exception body. So being able to parse the potential failure from that, we find is easier in the finally block in case there's an issue in the main processing as well for whatever other reason.
What I hear is Dustin's going to add a new example to this.
Can do. Yeah. So I was gonna say this is another, and there's just ripe with opportunities right now. That project we're trying to help and solve. But one of the problems that we ran into is that when we're executing our REST calls with our against our other service that we have standing up, that'll throw exceptions for if you have issues with either you messed up the body of the data that you're trying to send it, you don't have access, whatever happens. But we want to actually parse the details that come back because it'll have all of that good information as opposed to just the status code.
Yeah.
So we find that, the catch and the finally blocks become very helpful for that in order to send that data back to the user in a meaningful way.
Well, and so that kind of throws us into this catch block. If you can share my screen again.
Yeah.
So, there's a lot of debate on right or wrong on this, is what to do within this catch statement. Okay. Now, if you notice what we're doing in here is we're throwing a new runtime exception. So what I like to do is if there's not an exception, if it's not something we know how to handle, a good one that we know how to handle is like a invalid password error. Like,
authentication.
We know it's an invalid password. We need to go prompt the user to do something with the password. An IO exception where the file wasn't found or something, generally that's it's a software issue. It couldn't find some configuration file, couldn't find some file that the software expected. Found. Yeah, that's not something that we're going to propagate to the user.
The other interesting one with that too is if the software doesn't have permission to write to that file, and that goes back into what we talked about at the advanced Linux, making sure that the people have the right permissions and things like that.
Yeah, and so what I like to do is propagate the errors up and centralize the logging at a higher level, because if if you do, something like this, let's just say you have a logger defined, bear with me.
Debug.
No, this is going to be a warn. I'm going to make this a warn, right?
That was a test.
I'm just going to pseudocode this here. Log IO error.warn, right? And then we throw it up to the next level. And then the next guy does this. What we end up finding when we do this is we have the same log statement written 400 times in the logs. And it becomes very obnoxious because you're like, oh my God, this error is happening everywhere. And it's not. It's the same one. So
the problem you also want to keep in mind here is if you keep that log statement but don't throw the exception, that's even worse. So that's a major problem that we call exception hiding.
Well, sometimes exception hiding, this example down below here, looks like this.
Yeah. Where there's no logging, no throwing. If you get a log, that's something at least.
Yeah. And so exception hiding, this is a true scenario. And a lot of times what you'll see is something like this, right? To do add exception handling, right? Mm-hmm. And this is an ID. Usually someone will do one of those try catches with an ID. They auto-generate it.
Yep.
But then they forget to put something in the catch statement. And something as simple as a null pointer, right? Those are my favorite errors because it gives me a class name and a line number and we can go see what the problem is, right? Well, as soon as you're missing the class name and the line number, it becomes extremely hard to figure out what's going wrong.
Yep.
And to find this problem because of the exception hiding. Exception hiding makes one of those simple things to fix suddenly very, very hard to fix because you don't have the feedback. It's let's say a communication problem, right? Or a communication opportunity. Yes. Problems are opportunities here. Yep. But it makes it really hard to figure out because all of a sudden the software just crashes and then there's nothing in the logs. As a developer, the first thing we want to do is go look in the logs.
Figure out what happened.
And there's nothing. And so what you'll end up doing, and this will happen, I promise you, I literally promise you, if you develop software long enough, you'll track one of these down and then you'll go look at your revision control system. This is my lead into the next topic, right? And you'll try to figure out who added that code in. And what's the worst thing you're going to find is when your name shows up there, right? You don't want it to be you. You're going to be all mad. Oh, I'm going to track that developer down. I'm going to give him my mind. And you're going to come back to your name, right?
Yep.
So you don't want to be that person. And so avoid that. And there's kind of, there's a methodology for finding these problems too. This gets into, so
he's going to ruin the movie.
I do. I have a little game I put into this. So I'll let me move up here on the editor. Right.
So we'll ask a question for chat here. How many people have actually seen the movie Titanic?
Yes. So line 0.
Because Mr. Walsh this morning is going to ruin that movie for you forever.
Line 1 million. So this is my code.
You will always think of Walsh when you watch Titanic from now on.
You will. Think of me. Right. And so let me I'm gonna make this a little more realistic, right? I'm gonna put the statement in here, right? All right, so now how I try to find and solve these kind of problems is if I have a million lines of code, I'm gonna randomly go try to find, the center of the code. I'm gonna do
sorry, Matt.
Someone's seen this? All right. I'm gonna put debug and I'll put, some nice, easy to find, searchable message, right, that I can find when I search. Because then I'm going to go execute the code. And I'm going to see if this message prints out. Okay, if this message prints out, that means that the problem is somewhere in the half of the code from this line down, right? So if this is the halfway point, it's from line 500,001 to a million, line 1 million in the code. So now I know where to look, right? And so what I'm going to do each time is I'm going to then split it in half. I'm going to go to line 750,000, and I don't mean exact, but this is just take a guess in your code, right?
Yeah, we're assuming that this is a 1 million line file here, Hopefully
so now I'm going to go down around 750,000. I'll put a debug statement in. So what I'm doing is I'm splitting it in half each time, okay? And this is my reference to the Titanic. There's a scene where the main actor and actress in that movie say they're going to meet halfway each time. I don't know if anybody's ever seen the movie, but think of that scene, right? Essentially, we're doing the same thing. We're going to go halfway each time in our code to look for the debug, okay? And so every time you see that movie, you see where they say they're going to meet halfway, and they'll never technically get there. If they do that, it's a really romantic moment. Think of debugging code, okay? Because that's what you should think of. Is they're really doing the binary search algorithm, right? And so if you're at a movie, just tell your girlfriend, your boyfriend, hey, that's the binary search algorithm. Brian was talking to me about that. Said I should watch this movie for that reason. As I remember, it was a grueling 3-hour movie, which is, I'm not good with movies.
I was going to say, back in those days.
So as we think about the movie, we've gone halfway. So now at line 750,000, now we put a debug statement in. It does not print out. So now we know that the problem in the code is between line 750 or between lines 500,000 and 750. Mm-hmm. And so now we just split that one in half, right? And what happens is you can start narrowing down that problem very quickly by splitting it in half. You put it, somewhere around 600,000. Now you're quickly, within probably 5 iterations, you can narrow it down and look, oh, now I found the line of code where it's at, right? And so that's how I get to those problems and finding them. Guessing in the code or looking in the code for a catch statement that has nothing in it is a hard thing to search for. Code reviews should technically catch these things, right? But we're not all perfect, and we always inherit the code of others, so we have to be able to handle these situations. So think of the Titanic. If you have an exception hiding, just go halfway in the code each time, and it's just an algorithmic binary search. Go search and find it. So your computer science teachers would be truly excited that you're using an algorithm to solve one of those problems. So that's how we handle exception hiding. Questions on exception handling? All right.
Did we want to talk about checked versus unchecked real quick?
Go ahead.
too?
Yeah.
I think it might be good to just touch on that real quick. So you see on Brian's screen before it goes away, or we're not. But anyway, Java itself has the idea of a checked exception versus unchecked exceptions. So checked exceptions are one that you have to declare in a throws statement, or you have to, it doesn't allow you to call the method unless you're handling that in some way. Whereas an unchecked exception, you don't have to have throws clauses, and they will continue to bubble up throughout the call chain in essence.
Yeah. So the checked ones are the ones that you're required to put, here. So runtime is not a checked exception. So in this function, you would not have to put it.
Correct. Yep. An IO exception is actually a very good example of a checked exception.
Common,
yeah. So one of the things that I know most, Java courses that you'll find online, your college professors probably will talk about at some point, is that when it comes to checked exceptions, those should be the only things that you ever catch. Checked exceptions. You should never, never, never catch unchecked exceptions. But you'll see in our code that we actually do catch unchecked exceptions. We are catching throwable, which is technically the interface that is above all of the exceptions in Java. So you might think it's exception. That's not. Exception is actually a implementation of the throwable interface, being the other type of exception, or the other type of throwable being an error. And I think we might have another module that talks about this, Walsh, and I might be digging into that a little bit.
I think you are.
But in our examples and in our general best practices, we want to catch throwable because that'll catch the exceptions, that'll catch the errors, and that'll catch the runtime exceptions as they bubble up.
Yeah, I mean, I get into the whole, do you want to catch 100% of the errors or just 99%? Because there's a 1% where it's an error versus an exception.
Right.
So the throwable will catch 100%.
Yep. And the big thing there is that if you know that you want to catch the 100% of the time and do something or act on that, it becomes very easy to do that. Additionally, and this is something else that I want to put in the notes too, if you want to write a little note about this too. For Java and Spring specifically, one of the things that they provide is basically global exception handling for REST services. So for example, part of the best practices that we use on our projects is using unchecked exceptions to throw up the exceptions to that high level so that you're only ever handling exceptions at that level. And that should handle your throwables, that should handle your runtime, your other exceptions as well. And what that allows you to do is similar to what we have in our code in our examples here, is that you have the throws and your catch statements, and then that will bubble up to that global exception handling. So then you don't have to have your log statements all across your app. You don't have to have your catch statements all across your app. You can just throw the runtime exceptions or throw the custom exceptions that are unchecked up to your app to inform that global exception handling, what is actually happening within your application. And we find that, we, as part of our, so one of the anti-patterns that you want to avoid when it comes to exceptions is having exceptions and exceptional states dictate your workflow. So most of the time when we have exceptions and we're doing try catches across multiple exceptions, all of those blocks that he's now putting the ... are going to be the exact same. They're going to either throw the exception up, they're going to log it, they're going to do something with it in that you want to, tell the developer what's actually happening. But at the end of the day, they're all the same. So you can collapse them all into what we do with our throwable. So the other thing is that we don't want to have custom like workflow logic where you actually say that, oh, if this exception is thrown, I want to do this one case of, I want to go and, call this other piece of code and do this other complex logic, because then that usually is pretty expensive when it comes to the JVM. Now, granted, I will say, hardware is cheap these days. And so you can always throw more RAM at the problem. But if we can optimize the code and help clean up the code and make, the code better, it's better to do it that way.
I don't know. If anybody wants to pay my EC2 bill this month, they might think it's not so cheap.
Yeah, that's true. That's true enough.
Yeah. So here's the example. I commonly see this is what I see all the time in code.
Yep.
Right. They're doing the same, whatever that same line is. You can roll that up and just do a throwable. And now you've got, 4 lines of code instead of however many lines of code this turns out to be. It's, this huge block. And then that's the same with the whole throwable, right? If all of a sudden your function throws IO exception, now you're forcing everybody that calls your method to handle an IO exception, and they don't know what to do with it.
Yep.
So that's why we roll that up into a runtime exception. If there's, again, throws password not found exception makes sense because people know how to handle that. But throws IO exception, they don't even know what the IO exceptions are for. So be cognizant of what you're forcing on others.
Yeah, and as a kind of a last note, again, this is kind of the general best practice. There are some cases where you need to catch specific exceptions.
There are exceptions to all these rules.
Yes.
I'm sorry.
Exceptions to the exceptions to the exceptions. So again, going back to when we were calling external clients, for example, or external services, those can throw specific exceptions potentially that have additional information that you want to parse out. That is okay. I think that is like the one time where I might have multiple catch statements on my try.
Oh yeah. There's cases where you should have multiples.
Yeah.
When you're doing different things, right? If this ... is different, then you'll end up with 2 catch statements or something like that, right? Roll up the same ones that do the same thing, and you can order them differently.
Yeah.
So put the one that's doing something different first, and then put your throwable second.
Precedent. Because it'll go through the catch blocks in order.
Yep.
So if it hits that first one, it'll run that one and not run the other ones. So you want to make sure that you have that order set too.
Yep. Yeah. Awesome. All right. So if there's no questions, we can move on to our next topic.
Yeah.
Revision control. I'm very passionate about revision control. All right. Save. Moving over. All right. So revision control, it's really our collaboration tool as developers. It's our communication mechanism. It allows us, it's our safety net too. People don't realize it, right? Revision control can be your friend, right? I would implore that you, on a daily basis, commit your code to your repository. Hopefully it's a branch or something on a daily basis, right? Because I have literally come to work and found a white ring around my computer. And when I asked what's going on, they said, oh yeah, I caught on fire yesterday, so we hit it with the fire extinguisher. And needless to say, there was no code left on that box, right? That thing was done. And so, I will say from experience, writing code the second or third time is faster, right? But going back to revision control and pulling it out is even faster than rewriting it. And so what revision control does is it allows us to track our code, know what changes happen in our code, and collaborate. So Dustin and I can work together on code, and then the revision control system merges it together. It obviously cannot merge the same lines together and decide who writes better code, although we both know the answer is Dustin at heart, but we can't, the revision control system doesn't do that, but it does set up that collaboration framework, right? And so I used to do this really cool diagram in the past where I would talk about what most people use for revision control is a shared folder, right? And the typical thing they do in a shared folder is I'm working on file A, I write some code, I drop it into the shared folder. Dustin's working on the same code. He works in a different area. He drops file A in the shared folder over top of mine. And what happens is we're overwriting each other's changes. So all of a sudden Dustin's changes are in there and then my changes are gone. And this iteration happens because there's no revision control merging them together. And what revision control will also do is say, oh, hey, whoa, Brian, we have a conflict, right? And what it's trying to say is somebody else has modified the same file in the same line. You need to go figure out that conflict, because if we move forward with this conflict, we're going to toss out somebody's changes. And so if you ever work dealing with revision control and you see conflict, that means something to go look at. Okay. Ideally, we want to avoid it, because a conflict is usually a sign where Dustin and I aren't communicating clearly about who's doing what where, and we're writing the same code in the same area, right? And so we want to avoid conflicts, but it is a sign to collaborate on it.
Yep.
And so revision control provides that. It also provides history. Now, for those of us that are kind of smart about revision control, and we might have those managers that kind of want to know what we're doing, I like to write really nice, simple log messages when I check in my code. Right? Here's what I'm working on. I reference the ticket number I'm working on, and then I give like this very short, like one sentence. Here's what I'm doing. Like I'm talking to my manager. Because then what happens is, invariably 3-4 weeks later, my manager comes to me and says, Brian, what have you been working on the last 4 weeks? So I got really smart. I wrote this little script, and it would go pull all the revision control logs for my check-ins.
Yep.
And it would concatenate them all together, and I would email them this block, right? And then I'd moan and groan and make it sound like I did all this work, right? It was like one little script, and I copy and pasted it. But to write a summary of what you've done for a month, can you imagine like trying to remember? I can't remember what I did yesterday at work, let alone a month ago. So you've got to go figure it out. So take time when you do revision control, put nice messages in there. Because the other thing that happens is Dustin will do a checkout. He'll see a conflict, and then he'll wonder, what was Brian trying to do?
Yep.
And usually the code commits that I see are blank on the comments, or it'll be like finished code, or my favorite, code compiled.
We get the weekly or the nightly check-in.
Yeah, nightly check-in.
Yeah,
try to give reference, because if Dustin can see, oh, Brian's working on this feature. Oh, I know why he changed that now.
Yep.
Or, oh, he shouldn't have changed that. And then it creates a communication point. He has now context. He can come talk to me. Okay. So he can see what's going on, and it creates that collaboration. And that's what the revision control is supposed to be, as a collaborative environment.
I think you hit on a key point that I want to highlight here is the ticket number. If you're using an agile tool to track your issues or track the user stories you're working on, that provides context too. I mean, the minute that I can go and say, okay, I have a conflict, Brian was working on this other ticket. Let me go see what this ticket was. What was he trying to work on, and why are we conflicting? Why are we working on the same files? We can immediately, resolve that issue. And I can do that kind of outside of even bothering Brian and saying, hey, what were you trying to do here, by going and looking at the ticket? We've had multiple times on our project where people aren't putting the ticket numbers in, and then it's like, well, I don't know what you were working on. I don't know what you're doing, because it just says fixed code in your commit message. So it becomes very hard to collaborate.
Yeah. And so the other thing I'll warn you is, these revision control systems, you can see like check-in histories, and you can start running metrics. So be careful, don't let your management start running metrics on it. Julio did this the other day. Did he tell you about this?
No.
So they were running metrics on one of our old repositories for the rental car stuff.
Uh-oh.
And I think I might be able to find this thing. I think
was it like who committed?
Yeah, it was who did the number of lines of code, and but the one that he found was the most interesting is the average check-in time. So he ran a report, and so he was able to pull a report on the code I wrote like 10 years ago, right? And he said, Brian, it was really odd. Your check-in times were evenly distributed throughout the 24-hour period. I had just as many check-ins at 2 in the morning as I did 2 in the afternoon.
That's
and
awesome.
So he printed out this graph, and there was this check-in, like, I've checked in the same number of lines on average It's 24 hours a day. Like literally, he's like, there's no difference. Like most developers, it's 9 to 5.
Yeah.
Right? He's like, oh my God. I'm like, yeah, well, back in the day, you know, when we were small, like I would have to work in the evenings to get stuff done.
Yeah.
You know, often late into the night. So
Especially if there's a production issue at 2 a.m.
yeah. So he was running through the code and running history. He's like, oh yeah, you still had the most check-ins still. It was really funny and the disbursement. But where I'm going with that is you can start seeing some interesting metrics out of the revision control. But honestly, it's designed to be our tool as a developer to work for us. The other example I like to talk about, especially is when we start doing user interface development. You know, how many times have you written a user interface, shown somebody, and then they tell you, oh, you know, I really want to make these changes, right? You go make these changes, you show it to them.
This button should be blue.
Yep. And you show it to them. You spend, you know, hours and hours changing it, days even sometimes, right? You show it to them. They're like, you know what? I was wrong. I really want to go back to the prior thing you showed me, right? And so if you do revision control properly, you just roll back your last commit or your last series of commits to the point where you demonstrated it before and you're there. But most developers don't do that, right? So then they have to go literally make all those changes again, right? Like I said, it's always easier the second time. You know, believe me, I've learned these lessons. I've done these things, right?
Well, again, I think you alluded to this earlier too. If you're using branches, off of a main line for everybody to be using, if you've made all these changes on a branch and then your management or your customers say, no, we don't really like that change, you know, then you can go and immediately just go back to the main line and throw away that branch.
Yep.
It's very easy.
Or move back or something like that.
Yeah. Or if you're doing commits, you know, and have you committed the work in a meaningful way, you can just revert that 1 or 2 commits. You know, it's very easy to do those types of things.
Yeah. So revision control can be your friend. You know, how evil I was back in college. I actually had my own repository for my homework.
Oh yeah.
Right. And so I could go commit my homework. And this is before like the Google Docs and all were popular. But then I found I could access my homework anywhere. So if I, you know, went to class and forgot it, I could go print it without having to all run home and print it. So I could access everything everywhere through my revision control system. Or if I lost it or my computer broke or I deleted it by accident or the dog ate my mouse, right? You know, whatever your favorite excuse is.
Yep.
I had it, or I had a version of it, right? If I didn't like a version of a paper I was writing, I could go pull a prior version.
Yep.
Right. And so I found it was actually helpful for just day-to-day life, but I'm probably not your normal person there.
Well, like you said, Google Drive and the collaboration suites, like those now they've got the history of the versioning in there, which honestly is revision control.
Yep.
Just hidden from the user for the most part.
Yeah,
which is interesting.
Nice. Yeah, it's really nice. I mean, revision control is a tool to help us. And if we use it properly, it will continue to help us. So one of the things we like to do is walk through kind of the deployment process. Like we're going to make it simple. We're not going to do feature branches and stuff like that, but we're going to walk through what we're going to say is a typical revision control. You know, I miss the days when we're in person. I could have somebody up on the board with a marker. So I've pulled up Paint on my screen. So if perfect, Pat's ahead of me on this already.
It's our pseudo whiteboard.
I love it, right? I love it. Pat's a mind reader over there. Right? He's half awake. You can't see him. I have it. It's in my desk. Yeah. I stole it. It was Nick's pen on his desk. He didn't even notice it's gone. He hasn't been to work in a year. You know, I was struggling with the pen. For some reason, I'm better with the mouse, sadly enough. So let me do I'm going to do revision control. So most of the time, I'm going to make this top line time equals 0, right? I think I can do, look at this. I'm going to call it trunk they're using the word master now for,
or main.
Main is the other term. So if I can type, can people see that?
Yeah, it's a little small, but I know this is going to become big.
Zoom in one level. Does that get better? All right. Let's see. We've done that. All right. Let's see, guys. Bear with me. I'm going to see what I can do here. Can I select that bad boy?
You get drag and drop. Yeah.
I wanted to select the text. I don't know. I suck at Paint. We're just clearly demonstrating my inability to use Paint. Where's the little hand thing? All right, well, whatever. We'll go with it. This is fine for now. All right, so we start with the trunk and the master. Let's see. Can I do a little shape here? All right, so now we're going to start and we're going to work for 2 weeks, right? So we're doing an agile development process here.
Yes.
We're doing 2 week sprints, right? I don't want to rant about anything longer than 2 week sprints. You know what? I'm going to go with 1 week sprints because I actually want 1 week sprints.
Let's go.
I want to go smaller, more agile, right? So after 1 week, we've committed a demonstrable amount of code. So I'm going to make my little dot here. Again, I'm going to demonstrate how terrible I am at paint.
A little small.
Yep, sorry. So that dot is the end of our sprint. We're 1 week later. So where's my little text? So we're going to deploy version 1.0.0.
Oh, Elijah piped up in the chat. Get quick stats for your average of amount of time.
Oh, is it? Oh, sweet.
Get quick stats. Apparently,
Nice.
yeah.
I didn't come prepared. I should have had the printout that they sent me. Sorry about that. I just thought of it on the cuff. So here we have version 1.0, right? So what we're doing with the first circle here is we're going to tag the code. Okay, a tag is a snapshot in time that never changes. Think of like I got my handy dandy cell phone here. I'm going to snap a picture of the code, and that picture is that moment in time.
Yep.
You never change it. Never do it. If you find like yourself trying to do a commit on a tag, like just think of like Dustin standing on your shoulder yelling at you. Never, 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 right? Bad, bad, bad. So the tag, now you're defining that tag. Tag 1.0, that is there. Now, what we typically do is, I'm going to have to do some more paint here. You guys are going to see how bad I am with paint. Oh, man.
So inevitably,
I can fill it in.
Inevitably, we're software developers. We understand this.
All right.
There will be something wrong that we did in our 1.0 release, and that we'll have to do some sort of a patch or a code fix, a bug fix.
All right. So 1.0, I'm releasing it. Let's see if I can do this. Now I'm creating. No, stop. Now I want another one. I suck at this. Have I mentioned how bad I am? There it goes. All right. How bad I am at paint. All right. There we go. So I'm now creating a branch.
Yep.
So
this is now the release branch.
Yep. So we're gonna do branch. It's kind of weird now. I don't know why it's doing that.
Make it a little bigger. Yeah,
there we go. I don't know why it's doing that. All right, this is my funky drawing. All right, so now we have branch 1.x, okay? So now it's important to note that the tag 1.0 is now that moment, it's compiled, we have deliverables, we're sending it off to be tested. Okay, now when we do testing, it's amazing, we're gonna find bugs.
Yep.
Okay, so let me see if I can do my little bug. So I always do this little like
X, yeah.
3 X's. We'll find 3 bugs in the code, right? No, don't drag that one. Now all of a sudden it wants to be my friend. Oh, there we go. All right. Here's our 3 bugs. Okay. So what do we do with bugs? We go fix them.
Yep.
Right. So we're going to write code and pick your favorite place. Let's say we write the code on the branch because we're eager to test and deploy it. So now we need another tag here. See if I can do this good enough. All right. So we create another tag. Now
there is a problem with this.
Hold on. We'll get there.
Yeah.
0.1. I don't know why it's doing this now, but you know what? Usually we make fun of everybody else trying to draw on the whiteboard, but now we can just make fun of Brian trying to use paint.
Well, I mean, we understand now why it's so hard to draw on the whiteboard.
Yes. It's even harder to use paint. Pat over here is like he's like, oh my God, this is painful to watch. It's okay. He's half asleep. All right, so now we fixed the bugs. We've 3 bugs, so we fixed them, right? We've tagged a new version 1.0.1, and we'll talk about version numbering later. Let's just bear with me for the version number here. Now, that's on the branch. Now, what do we have to do here? Dustin's itching. Go for it, Dustin.
So, on the trunk or the main line, those bugs still exist because we found them within the release branch. And since we, merged or we created that release branch, we created that from all that tag. From that tag forward, no matter which branch you're on, those bugs will exist. So we need to pull those bug fixes back into the master or the main branch.
So we need to merge those fixes back.
Yep.
So that's the green line. So we're going to merge those fixes back to the main. If we don't do that, we make the job of our testers really simple because they always test the same problems they had previously. And it's really embarrassing when they find them in the next release. And we'll get there with the next release. You'll see how this works. And then it makes their job easy. They're really happy. Like, look at these dumb software developers yet again. They forgot to merge them.
Job easy.
Yep. Found the 3 bugs, and then they report it to their management, all happy and proud. Like,
I found 3 bugs
yep,
again.
3 more bugs, right? And so, with our agile paradigm, right, we're going to go write more code, okay? And when we write more code, we're going to spend another week, right?
We'll write more code while the testers test 1.0.1.
Yep.
Yeah, we'll let them test that now that we found those 3 bugs before we release it.
So a week goes by, and my timeline is probably not as even here, and my dot isn't as big, but bear with me, right? So what happens, a week goes by, we write some more code. Bear with me, I'm going to do 2.0.0. We'll talk about version numbering later. Might not be the right theory if we talk about version numbering, but bear with me. So now, we tag the code. We're tagging the code again so that, why? So we can have a release number that the testers can refer to.
Yep.
Because if we don't tag it, what do they say? There's a problem on master. When did the problem exist? It existed at 2:33 UTC time. Remember UTC time?
On Tuesday.
On Tuesday, right? So now, but I fixed that at 2:01. Is it in there, right? Well, the tag creates a snapshot, so we can go talk about that code. We have a reference. We can build that code. We can test that code. And more importantly, we can go deploy that to production, right? Because, how long is it going to take us to forget that it was 2:30 on Tuesday that we deployed this code to production, and we have to go back and make a change to that code? What's in it? Well, everything from before 2:30 on Tuesday. How does that sound, right? No, that's not very professional. So we want everything in this branch. It's the tag. So version 2.0, here's the tag. Here's the code that goes with it. And then we can branch off the tag to add more to it, right? We would never change a tag. Okay, so here we go. Let's branch off of this, right?
Create another release branch.
We've got another release branch. Look at that. I'm getting straighter with the lines. It's looking even better. Do you think I can do this? It's going to be terrible, right? It's not going to be even close to straight, is it? It's close enough, right?
Close.
Not too bad. All right, so now we're going to create branch 2.x, and I have no idea why it's doing that weird. All right, now we have branch 2x. All right, what do we normally have to do still? All right, let's go find some bugs. All right, but these are going to be new bugs because we merged our code. So we have new bugs, new opportunities. We're going to call them opportunities. We're going to have the opportunity tester opportunity fund. All right. Look at my
Keeping
X's.
those testers employed.
These X's are perfect. These are great. I'm terrible. All right. At least everybody can laugh at my paint drawings, right? Yeah, I'll print this and hang it on the wall to laugh at forever.
All right.
Pat is like our graphics person too, so he's like visibly hurt by this. He's like
twitching.
That's the lack of sleep in my eyes.
He's like, I am trying to make you guys more professional, but I showed up this morning and you did this. I'm never a lever again. Like if you see him come grab the chair and throw me out, you'll know why. Right?
It's just the hook.
He's been helping
Pull you
us
off
get
screen.
more professional with these presentations, and then this morning happened.
Yeah, the cane.
Yeah. Whap, whap, whap. I can't help these guys anymore. Did you see Brian in paint this morning? All right. All right. So now we've got the 3 defects. Okay, we're tracking them. Now we're gonna fix them. Right? We're great developers. We fix them. All right. So let me get my handy dandy tag. So we
fixed them.
we fixed the bugs. We've done a great job. Okay. Now we're gonna do another handy dandy tag here. What version number is it? 2.0.1. Good job.
Woohoo!
Sweet. Now, oh God, here we go. I'm getting there. Now, this is where it gets real interesting. We're going to get into merging, Dustin, right?
Oh, yeah.
You want to take it for the merging?
Sure. Well, let's see. We'll throw it to the audience. We're on a little bit of a lag here, but what branches do we need to merge these fixes back into? And we'll give it a couple seconds here just to have people jump in. But yeah. So as we move forward, we've got branch 1.x and the main line. And because we found the fixes after 2.0.0, we need to merge it back into both of those branches. Because those bugs probably exist within the branch 1.x. And they probably exist within the 2.0.0. Or at least we need to go figure out exactly which branches those things those bugs are in. There is a case potentially that those bugs are not in the 1.x because it was something that we introduced between 1.0 and 2.0. But more than likely, they are bugs that we have already had within both of those branches.
Yeah, so where Dustin's getting at is if the testers actually missed one of these bugs.
They could have been there already.
Yeah, so it could have been in there previously. So if they missed it, that means it would actually need to be merged into the 1.0. And that means we have a problem. Let's say that 1.0 is in production here.
Yep.
Right, where's my little...
Your dot.
I'm going to do this. This is how we put things in production in Paint. Yeah, version 1.0 is in production now, guys. Oh man, we might be shafted. It's not in production now. No idea what it is now.
I just retype it.
It's baked in. You're gonna have to write it again.
All right, we're gonna have to deploy to production again. We have a botched deployment, folks. All right, first deployment got botched. We'll see if we can. Oh, there we go. All right, we're in production now. We had a partial deployment. Look at these problems. Pat is over there visibly laughing.
Yeah, so if those bugs that we found on the 2.0 branch, if they were in the 1.x, for example, if they occurred before we tagged 1.0, then we need to merge it back to the 1.x branch. If it's something that if it's a bug that we had after the 1.0 branch, if it's something that we introduced in that second sprint that we had, then it only needs to go back into the main line because it doesn't actually exist on 1.x. And so this is where you have to be careful when you're merging between all of the branches because you have to figure out exactly what you want.
Well, and this gets more interesting. So let me get to, I love adding the third week here.
Yep, we got a couple questions in
What
chat
are the
here.
questions?
So Matt's asking, if they missed it, wouldn't you want to merge the fixes into branch 1 and the main line? Absolutely.
Yep. Yeah, that's
absolutely.
what this second line is
Yep.
when they mix it.
And then Mohammed also asked, why would you need to branch 1.0 if it is identical to main?
So it's only identical to main at that moment in time.
Yep. So after the 1.0 tag, 1.0.0,
So right here.
you have that blue X that Brian added to the main line. That would be new code that is no longer in branch 1.0 or 1.x and is only on the main line until you tag 2.0. And then it is going to be in the 2.0 branch and the main line.
Yeah, I mean, if you're the only developer and you're doing all this on your own and you know you've stopped coding, yeah, it might not make sense. But in the real world, definitely, we're usually on a team.
There's multiple people.
And usually the team is itching to write more code, right? You know, there's the one person that's helping with CM that's doing some of this. Everybody else, as soon as they tag, they're off. They're like writing more code from that instant. They're on the code keyboard writing away, right? Yep. So that snapshot is changed immediately almost. And usually it doesn't even compile when they tag it.
Right. So for our example here, you don't need to merge the fix for the blue bug back into 1.x because that does not exist on that branch. That would only go back to the main line. But the other two X's, let's say the two other issues, let's say the testers missed it in the 1.0, you would have to merge those back into the 1.x branch.
Whoops, I'm on the circle here.
Yeah. So this is where it starts to get pretty complicated. And one of the best practices that we have as well.
It would be better if I did it like this so you could see.
Yeah, there you go.
That bug has to be merged up because it happened prior to this.
Yep. So one of the best practices, and this is more of a release cycle issue than a revision control issue, is you don't want to be managing all of these branches all the time.
Well, don't get ahead of us yet.
Oh, do we have a note about that?
Okay, there. Hold on.
All right.
So let's do one more deployment, and this is that it's pertinent to what you're talking about now.
Yeah.
So we're working on another week, 1 week sprints. My dream, right? I'm dreaming. Most of the time they're 2 weeks. 3 weeks is just not acceptable. I'm sorry. If you're doing 3 week sprints, those are marathons. I hate them.
So
I'm adamantly opposed to them.
So that's the question.
Tags 3.0.
How do you know where the defect came from? So one of the ways that we're able to debug that and figure that out is running the same set of tests across the different the different branches. So for example, let's say we identify that the defect was in, the 2.x branch. We'd have to go and test the 1.x branch and the main line to see if the bugs were in there. If it's something that we then identify is in, all of these different branches, Brian's going crazy here.
All right, so I'm making our 3 bugs, right? So
Yep.
we tagged. Whoops, I'm screwing things up here. Hold on.
So you can't just look at the code necessarily and know, oh yeah, it's in here or it's in there. Most of the time what we're doing is working with the test team to figure out and testing multiple versions across multiple environments to figure out exactly where those bugs are.
So I'm getting ahead of ourselves. So we tagged. Let's branch. All right, let me do my branch real quick here. Whoops, something spelled wrong. Oh, we have a
Failed branch.
That branch failed. There's another branch now. My mouse skills. There we go. All right. So we've branched, right? So now what I was trying to do, and I'll do it a better job now, is we're going to create 3 bugs. Oops. Oh, geez, I'm terrible. Paint skills. I'm getting ahead of myself. Get so excited here. All right. So here's a bug. Put it in a different color. We'll help everybody.
Testers
out
found
here.
it on branch 3.x.
Yep. And this is actually quite common, right?
Yep. Like, oh, hey, this has been a bug the entire time, and we
Yep.
just now found it. Yeah, okay.
All right, we'll do different colors here. Because we can't put it in front of 3 because that would imply that it's not even
That's
in there.
new work.
Yeah, it shouldn't be in there.
Well, I mean, we can talk about that, but
I think we have enough problems to solve already.
yeah, I think so.
All right, so now we have 3 new problems or opportunities here, right? We have bugs that have occurred in different spots. So where do we merge each of these 2?
Yep.
So this first one, it existed before, right? So this is where it gets complicated, right? So when we have, we're on branch 3, now we're finding defects. Now we have to research to figure out where they came from. So let's say we did the research. I topped the screen already. Let's see, that's a touch screen. See, look at that.
Uh-oh. He's touching the screen. Leaving dots.
See, I could use my pen, and I'm even worse. My hand's not stable. See how terrible I am. So now we have to research, right? And now we have to figure out, okay, so this first bug is way back in the day. So it has to be merged to all 3. Oops. All 3 different
Yep.
places, right? Because it exists everywhere. Whereas the yellow one exists between 1 and 2. So it does not exist in 1, right? And so what I do is there's a little finger test. If you take here,
Ronnie, we'll get to your question once we're
and
done
you
with this.
slide your finger up, look, it hits 2.0 and it hits 3.0. So it doesn't hit 1. So you only need to merge. Whoops. Oh, God. Oh, man.
Oh, no.
I've really messed up now.
The merge was broke.
No idea why it's doing that. All right, let's click off of that. See if it'll let me. There we go.
Nice.
All right, so for yellow, I need to go,
Yeah, it's after the 1.0
Yep.
release.
and then I need to go to main, but it doesn't have to go to the 1. And there's a question. I'm sorry.
Yeah, we'll get to that once you're done with the merges, because that's we can get Walsh on his soapbox.
Oh God, you don't want to ask that question, do you? All right, yeah, I love that, man. Let me I get a name and address. I'm just kidding. All right. So now we're getting to the third one, right? So if I put my finger here, right, and I'm sliding it down, it only hits 3. So I only have to merge the third one back to the main. Okay. Now you see how making all these decisions is time consuming.
Yeah.
Right. So the more branches we have, and the further behind we are getting things out to production, the more work as a developer we have to do.
Yep.
And the more opportunities we have to forget merges. See how many lines there are here? It's very quick and easy,
6.
right?
6 different merges for those 3 bug fixes.
I run over to Dustin's desk at lunch, say, let's go to lunch in the middle of merging things. He's like, sure, let's go out to lunch. Of course.
I'm going to forget the 4 that I started.
Yeah, we have this huge lunch. He loads up on dessert. He comes back fat and happy, and he falls asleep in his desk right after lunch. And he's like this sugar high. He doesn't remember anything that happened that morning. So he immediately moves on to his his boss, Pat, runs over with this emergency because these never happen. There's a problem in production. You got to put the fire out. So he goes and he does that.
Mm-hmm.
And the next day he comes back and he realizes he was merging stuff. He's like, I must have been done. So he just
Oh,
moves
yeah.
on.
New code.
Yep.
I got new code to write.
Merging's not fun. I'm moving on, right? So he just moves on, right? So now we're in this weird state. We don't know where everything's merged to. The testers, they're going to have a field day with version 4.0.
Yeah.
Right? They're going to find errors everywhere, okay? And this happens because people don't follow the process. Now, this is my shameless plug, right? So if we automate, where's my little circle here? I need to find some color that I'm not using here. All right. So if we can automate our configuration management process, so automate our tags,
Yep.
automate our deployment to our staging environment,
Yep.
right? And here's my shameless plug, automate our testing, right? So this is all push button, deployments. If we have automated tests, right? Those tests run sub-second. If we find problems, we add more tests.
Well, even better, the tests automatically run out of band, so you don't have a human spending time doing them.
Let's say they run every commit, right? Every time you do a check and they're running. So you're automatically testing your code.
It doesn't, at that point, it doesn't matter how long they take, assuming that they don't take forever.
Yeah.
You have them not running with a human. You have another resource to go and use to do something else more productive.
Yep. So if we automate those, let's just say they take a long time, an hour in computer times, right? That's a long time, right? So let's say this automated test, automated deployment, they take an hour, right? And they pass. Right now, if we automate our deployment process to production, right, most of the problems we see in software are people problems, human problems.
Yeah.
Right. If we automate things, we're removing a lot of the opportunities to have human problems. Okay. Now, if we automate this process too, now our time to get things to production are automatically, with automation shrinks.
Yeah.
So now if we're able to move things to production faster, right? So now what happens if during this whole process?
Now, again, I will say the one thing that we can't automate is fixing the bugs.
Yep,
Obviously,
yep.
That's the one thing that we still need the developers to go and do manually.
Yep.
But then all of the automated processes to go and retest those things should be automated.
So let's say we deployed branch 1 to production in our example here, and the automation happens, it was quick. We come back to our 2 weeks later for branch 2 here, okay? Now, if it's an hour to test and deploy, right? If we just move that to production right away, right? We do another deployment to production right away. Do we care about merging anymore?
So 1.x?
Yeah.
We don't care about the 1.x branch
All
anymore.
of a sudden, merging becomes inconsequential. Same thing, if we get to 3.0 here, if we get to 3.0 and we can deploy within an hour or a day, then the merges go away, right? So automation allows us to get rid of a lot of the merging nightmare because we know we're going to go to production right away.
Yeah.
We don't have 7 weeks, right? I'm looking at Ronnie here. We don't have 7 weeks to wait and fix problems in production during that 7 weeks. So the longer our time to getting our production code out there, the more opportunities we as developers have to make mistakes and the more distractions we have to development because we're being pulled away to fix things in other areas. So without getting on my soapbox too much, I'm already there. Automating testing, automating deployments, automating all of these processes around development help us developers be more productive. The other thing it does, and this is where subtlety is, management, right? Every time we make a human error, we actually decrease our management's confidence in us. So by automating, we're improving our management's confidence. Like every time we have a deployment that's botched, they want to slow down and not do another deployment, be more careful, right? So, we're going to be on week 20 of our deployments because, whoa, slow it down. We keep making all these mistakes. Well, as we make these mistakes and we're on week 20, now we're going to, invariably, the next deployment is going to be botched because we're 20 weeks behind.
Well,
right? The further that gap is, the worse it's going to get.
The more time between release cycles, the more code that has been put in, which means there's the potential for more bugs to go and fix.
The higher potential, right? It increases. And it increases exponentially as you add more code. So,
and we're not saying our developers are bad, but everybody makes mistakes.
Yeah,
And that's okay.
Yeah. Even with testing, there's going to be stuff. And so what I'm going to say is you're going to have to add more and more automated tests. And you're going to, every release, you should be adding more automated tests because you should be adding new code in theory, right? So you're going to improve upon this, right? And there's going to be things that go to production. And the answer is, oh, yeah, we just wrote another automated test to fix that in the future. So we'll identify it. It doesn't mean that everything's going to be perfect. It just means our processes are continuing to get better. It's the agile mentality, right?
Yep.
And we have more time to focus on development and processes because we're doing this automation.
Right.
And so that's the argument you need to make with your management. So I'm going to look at Ronnie's question now. So how about 2-week sprints turning into 7-week sprints because the head of production refuses to release if everything isn't perfect? Well, so my argument here, Ronnie, to your question is...
Yeah, he said he was just venting, but...
Well, you should still do 2-week sprints.
Right.
Your release cycle can be different from your sprint cycle.
Yep.
Now this would, I would also argue too is that it depends what you're trying to do, but the whole agile framework is designed to have things not be perfect, but be moving forward. Now there is, I'm going to say there's a difference between perfect, acceptable deploy to production and unacceptable deploy to production, right? There is definitely an instance where I would say, hey, that code's unacceptable to push to production. Right. But there are acceptable cases where there's workarounds or, we're getting a feature out the users really need, but it might be a little buggy. There might be a few bugs in it that we know about. That's okay sometimes to push it out to production. I think it gets to how you manage their expectations.
Right.
And so, I would argue that if it takes 7 weeks to be perfect, that would probably mean that you're doing some of those fixes as part of the agile process.
Right.
So they would be in your 2-week sprints. And I would argue towards, you have to figure out how to prioritize, right? Prioritize and get those things to push things to production faster because that makes your life easier.
Yeah.
So,
one of the agile improvements we made when we released that one product to production for those 4 weeks that we had debug on is that we actually added a set of story points to the sprint to help work with production issues. Because we knew we were going to be getting into that situation. So we immediately said up front, hey, we know that we're going to be spending some time fixing production bugs. Let's account for that.
And so I want to step back at the 50,000 foot level. Like, why did we do this diagram today? Right? We want everybody to understand that, you're going to write code on the trunk, the main, the master, whatever you want to call that. And honestly, if you have a team of just 5 people, there's going to be continuously, merges in there. It's going to be very active. Right? So the whole concept of tagging and branching to do your deployments is needed. A lot of people do feature branches, and that's fine. We don't want to I struggle with Paint enough to just do it with just this simple example. We start adding feature branches and it gets more complicated. But the concept is you still need to do tagging and branching for your releases to be professional, and that allows us to account for these things. And if we follow those simple processes, it allows us to release. Imagine if we didn't do a tag. Right now we're saying, oh, wait, no, stop writing code. Stop.
Code freeze.
Code freeze. We have to get it to compile. Oh, wait. We need to wait 7 weeks to get everything where we can do our release. So if we take Ronnie's example, I'm going to pick on Ronnie's example here is let's say we have a team of 5 developers. Well, now we've got 3 developers working on fixes, 2 developers that are told to work on their own box on stuff, and they're not going to be doing merges.
Work on your own long-standing branches.
It's going to be a disaster.
Yeah.
And we're going to propagate problems because we're not following a process. So, and I'll say the other dirty secret is I'm usually the guy that does revision control on the team because I push this simple process, right? And everybody thinks I'm God, right? Because I know this thing that takes an hour to teach everybody else. And really, it's because nobody else wants to learn it. Nobody else wants to do it. It's not hard.
Boring.
Yeah, it's boring. It's the things that nobody wants to do.
Yep.
But these are we talked about differentiator skill sets. These are differentiator skill sets. Nobody wants to learn it. I've taken the time in my career to learn the crap tasks that nobody else wants to do. And everybody thinks I'm smart. I'm not really smart. I just do the crap tasks. And I do them really well so that I can spend less time on them.
Yep.
And I automate the crap tasks because that way I don't have to do them a lot.
Right.
And you know what? When push comes to shove, who do we need on our team? The people that know all these weird, odd tasks and knew how to, they know Linux, they know how to do deployments, they know how to revision control. All these things that we're focusing on, are the things that people want on their team. Nobody wants to do it. So be that person. Then you're needed more. And then you learn more about the process.
Yep. And to Matt's question we have in here, so he's asking about managing expectations and whose responsibility is that? Is that managed? Is that the product manager? Is that the developers?
So let me. I literally was just having a ranting session on site about
I
managing
assumed
expectations.
that you wanted to take this one.
So
yeah, no worries.
So I think that it's everybody's job to manage everybody else's expectations. It's my job as a developer to manage everybody around me's expectations. The developers on my team, the managers on my team. It is my manager's job to manage the points of contacts that he deals with, the expectations. As a developer, I shouldn't be jumping my manager and talking to the end customer and managing their expectations.
Unless told to.
Yeah, if I'm told to, that's fine.
Right.
But I should be managing my direct managers or my tech leads' expectations. And so then he understands, right? Here, it's very simple. If you want to know if you've done a horrible job managing expectations, it's obvious right away. If somebody is surprised by anything you do, you have mismanaged expectations, right? Now, if all week it's Scrum, it's stand up, and at every meeting with your manager, you're like, man, I'm falling behind on my task. I'm really getting pulled in all these different directions. I don't think I'm going to complete my task on time. I don't think, and then you get to the end of the week and you say, I didn't complete my task on time, and he's surprised. Like, that's his fault for not listening because you've said it 7 times or 5 times, right?
Yep.
All week you've said it. If all week it goes like this, Dustin, I'm on track. And then Friday, I missed my deadline horribly because I've been working on all these other things you've been asking me to do, Dustin, right? And you're surprised by that. Well, whose fault is it? It's mine. I didn't manage Dustin's expectations throughout the week. I have to tell him these things. And so everything in life shouldn't be a surprise, right? If you're going to be out on Friday, don't wait till Thursday to be like, Dustin, I'm out tomorrow. Right now, that's a surprise. You know, say, okay, you know what? In 2 weeks, I find this is what I have to do. In 2 weeks, I'm going to be out, Dustin. It's on that Friday. I'm doing this, right?
And just had this conversation.
And then literally like a week later, I need to repeat it. Hey, Dustin, remember I'm off this Friday. Because when I tell him 2 weeks, he's like, yeah, that's in 2 weeks. I don't care. That's literally what went through his mind. It literally went. And then when a week later, I remind him, Dustin, remember I'm out this Friday. He's like, yeah, I kind of remember he said that, right?
Yeah,
and then Thursday, when I go to Dustin, remember I'm out tomorrow. He goes, oh, crap. I know you told me 3 times, but I forgot. Okay. He's not surprised by it. Now, he mentally is surprised because he knows he forgot that fact, but he knows you've managed his expectations for that, right?
Yep.
And so managing expectations is our job on a continuous basis to the people around us at home, right?
Yep.
You know, manage expectations with everybody around you at home, right? Manage expectations for everything you do and find out nobody should be surprised around you, right? If you're doing a good job managing expectations, nobody should ever be surprised. Right. And that's a simple measure. Right. So it's everybody's job to manage expectations. It's your job to manage the people around you. If they don't do a good job and there's a surprise, that's on them.
Right.
Right. That's them. But managing expectations is huge. I think there is a book on the Rising Leaders Challenge series on managing expectations.
Yeah. I believe the book is called Managing Expectations.
Yeah. It is one of the few books I can't find on audio.
Yeah.
That I love that book.
We have a copy here in the office. I know.
Yeah. Sadly, you know, early in my career, I was horrible at managing expectations. I know that might be a shock to everybody, right? And I read that book. And
Problems
it was one of those
opportunities.
Yeah. Well, it was one of those terrible things where you read the book and you're like, this is so obvious. I'm a moron for not knowing this, right? Like I read books all the time and I get this concept and they're like, you know, it's a great author when they make you feel dumb because you're like, wow, I can do this, right? Versus, wow, that's too hard.
Yeah.
But managing expectations, it's a communication thing. You know, it's just learning to be honest with yourself, right? Most of the time I find developers aren't honest with themselves. No, I'll get it done Friday. Oh, no, I'm good. And then Friday rolls around and it's like, it's not even close, right? It doesn't compile. It's not even near where they're at.
Ideal situation, they could have gotten it done by Friday.
Yeah.
But everything
it's not going to be done by next Friday.
No.
Right. And
no, not at all.
Manage expectations. And really what I say is don't lie to yourself. Be honest with yourself about where you're at.
Right.
And so, you know, Dustin and I were just pushing, you know, with Agile is story pointing and more importantly is being able to understand how long things take. Right. I need to know as a developer how long things take me to do or other people to do so that I can estimate my own tasks. And someone just told me they're horrible at it. I said, well, you need to get better. They said, why? Well, you know, you have to be able to know how long things takes to manage people's expectations properly. And someday, if you ever want to be a tech lead and your manager comes and says, how long will that take? I don't know. When the developers get it done. Do you think that's
2
the answer
years.
he wants to hear? Right? No, he wants to know, like, you know, it's one thing to say 2 weeks and it takes, you know, 2 weeks in a day, but to tell someone 2 weeks and it takes 2 years, I mean, I'm thinking you're not going to have a job at that. If somebody told me that about 4 weeks later, I'd think I'd be like, all right, it's time for you to find a new career or job, Dustin, or something like. You know, there's something about
and it
being
shouldn't be
totally
predicting
wrong.
the stock market.
Yeah. Yeah. So managing expectations, I can rant forever. I think it's a good one.
Yeah, Ronnie put another comment, and they were using Subversion as well.
Well, I don't mind. I mean, honestly,
Yeah.
it's a tool. I grew up using Subversion.
It's better than shared folders.
It's better than shared folders. It's better than CVS.
Yeah.
Git has some better things to it. But honestly, if you can use subversions and branching and get a lot of the same things you get with Git.
It might be a little antiquated. It might be a little harder.
But you can still accomplish most everything. It's how you use it, right?
Yeah.
And without getting too much on my rant, manage expectations. Really, I find in life, it's not what you do, it's how you do it. Mm-hmm. And so have those hard conversations.
Yep. So that is
huge. I mean, going over budget, over timeline, it's a bad thing, and you have to manage people's expectations. Mm-hmm. I mean, imagine it. Let's hit home, right? Imagine if the school came back to one of you college students, right? Most people are in college, and said, "Well, we told you it was going to be $10,000 for this semester, but we found out that the cost was really $50 million at the end of the semester, so we're going to send you a bill for $48 million, right?" You'd be like, well, what do you mean? Like, that's not fair, right?
Yep.
And so essentially as software developers, when we blow our budget by 2 years and blah, 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 that's what we're doing.
Yep.
And so imagine the poor customer, right? The word surprised wouldn't even be like big enough, right?
Disappointed, right? Angry.
So imagine that. So that's where it's our responsibility to be better at these things.
Yep.
So.
And I mean, when we're talking about over budget and, very, out of bounds when it comes to our predictions, I mean, part of the reason why we push agile and why we try to, have our teams run agile as much as possible is because you are able to manage those expectations on a 2-week basis.
Well, and manage expectations up front too.
Yes.
Right. I mean, literally, I was yelling at my developer team the other day, right? They missed the deadline and they said, we didn't think we could do it from the start. I was like,
why didn't you say that in planning?
Yeah. Why didn't we ever agree to a deadline.
Yeah.
Don't ever agree to a deadline. And if it's a forced deadline, somebody else, like, go in and say, look it. Like,
I think
we need 3 weeks. Like, or, like what I'll say is, all right, fine. You guys think, how can we do it in 2 weeks? Right.
Yeah.
Like,
what is blocking us?
Do we need more resources? What do we need? And then let's have that hard discussion day one. Yeah. Because it's a lot easier for me to go to my management day one and say, look it guys, this is not going to take 2 weeks. We need 3 weeks at best. And likely we're going to need 4 weeks.
Yep.
Right. And it's easier to manage that expectation up front. But if 2 weeks down the road we miss it, and then everybody on that team says, I know we're going to miss it, right? Like, I'm surprised, but now I'm pissed, right? Yep. Now I'm like, wait a minute. It's the secret that everybody's keeping from me.
Oh, yeah.
Right? And you don't want to be that. Have that hard conversation day one. As soon as you think there's a problem, just raise the concern, right? Be that person on the team that is open and honest, right? How we do things, the how is always hard, right? Usually the easy thing to do is the wrong thing. Because usually it's the ignore it, let's not talk about it, we'll wait till it's a problem, right? And that's mismanaging expectations. It's not doing the right communication. Do the hard thing. Have the open, honest communication. Because what I hate, the other thing that happens was all the time, I'm mentoring somebody and they fail a class, right? Literally, we deal with this out here. I've seen multiple college students come to me and they come and they say, Brian, I'm not going to graduate this May. I failed differential equations. That seems to be the one, right? And I'm like, what do you mean? Like,
and this is an April, May timeframe.
This is usually like a week before the end when there's nothing that we can do about it. And I'm like, do you realize we have like 35 college students that graduated last year sitting out here and they all passed differential equations. And I would get 34 of them to help you so you don't fail, right? Let me know about a problem so I can help. Yep. Like, I'm not upset that you're failing. I'm upset that I missed an opportunity to leverage the 34 people sitting in our office to help you succeed.
Yep. Right.
And it's just as a leader in a software team, like, I want to know ahead of time because I want to be able to help. Like, we are going to all sink in the ship together. Let me know.
Yeah.
Right. And so make sure you let your management know. And if they don't appreciate it, you're working for the wrong organization. I'll just say that. Right. Yeah. Have those hard conversations and have them in life in general. Solve those problems. So, all right. So I ranted enough about this. Hold on, Pat. I'm saving this for you. Okay. Dude, I'm saving this paint.
Matt, I think to your point as well, I think most of us were thinking that, yes, Cyberpunk was another example of managing expectations.
There's a ton of, like, we don't have to look hard and long for managing expectations. So I did promise that we would talk about version numbering, but first I do want to talk about one other thing, repository structures.
Yep.
So it doesn't matter what skill or what technology you're using. There's generally, if you look at repository structures, most people start as a monolithic repository. Can we share my screen again? Well, here I'll do
And this
it.
is going back even to the Subversion days to talk back to Subversion.
Yeah,
You'll
my
see that
example is in Subversion. So
we're using SVN as the.
so hold on. My example will cater to Matt. Is it Matt that was
No,
using?
Ronnie.
Ronnie. All right, Ronnie.
Yeah.
My example will cater to you. All right, there we go. I'll make it a little bit bigger here. All right, so most of the time we start with this monolithic repository structure. Oops, I lost my tabbing. Bear with me. I can't do two things at once here. And this little keyboard's terrible. All right, so most of the times, so our Subversion and Git examples, doesn't matter. You still have a Git, or in Git you still have the master, the trunk, the main, whatever you want to call this. This is that. And so usually within there, most of the time we start off with one project, right? And if the team is horrible and they fail, they're disbanded and we get rid of them. So this isn't a problem, right? But most of the time we have awesome teams. And what do we do with awesome teams? We give them more work.
Yep.
Right? If you're on a team that's not getting more work, well, look in the mirror. You're a bad team. So good teams get more work. So typically it starts with this. They have deliverable A, project A, whatever you want to call it. And then they're rewarded with project B, and then they get project C. And next thing you know, they have a ton of projects within their project or within their repository. And that's when we get to this monolithic repository. That's a sign of a good team, to be honest with you. They're doing a lot of good work, right?
Yep.
So
You're
then
getting more and more responsibility.
Then we do branches. Remember, if you branch, everything gets copied over in the branch, not just what you're releasing. If you're releasing one of the products, branch everything still. And that's gotten better with a lot of the automated branching and a lot of the automation, because in the past, a lot of this was done manually.
Yeah, so SVN, you had to copy the files over manually yourself. Git handles it very differently with the way that it handles
it's all automated,
the branches.
so
well, it's to the point where you branch and the files are the same because you're all pointed at the same place.
Tags are handled automatically. And so tags, same thing. So what you end up with is this trunk, tags, and branches where all the deliverables in there, monolithic. Everything's in there, monolithic, right? In the term.
One repository.
And I will say this is not an industry standard. I'd like to make it an industry standard. This is a Brian standard that we've portrayed out to our organizations, and we've used it. So it does get a little religious, but sorry, there's no other standard, so I will create it. So now, if we move down here, let me see if I can get hold on. Well, that didn't work real well. My notepad skills are still desiring improvement. Oh, geez.
They're better than your paint skills, though.
Oh, yeah. My fingers are a little cold this morning, so they're getting trigger happy. All right. So now we have a deliverable-centric repository. So I think it's been about 5 years now. There was this really big push to make everything deliverable-centric.
Microservices.
Yeah, microservices. So then there was this weird push to make every repository deliverable-centric, right? And I'll get into that in a minute. But so deliverable-centric is where you have one repository for each product. So within each, then you have your tags and branches. So instead of having multiple projects here, you have a separate repo for each project, right? Now, so what I was asked like 5 years ago to go take all these monolithic repositories and turn them into deliverable ones, right? And so I did it for a few teams, and let me tell you, it was a horrible experience. It didn't work very well because all their scripts didn't work.
Part of that too is if you already have a structure, don't try to change it halfway through. That's part of the problem that I've seen, at least, because I've also seen deliverable-centric projects if they start that way, can be successful.
Well, and they're a lot of work because like then you have to release everything separately, but a lot of times they depend on everything. So like my team was complaining that like, look, when we release like all 40 of our projects, we now have to release 40 and do 40 separate versions, right? So it was easier when there was 40 projects in one, right?
I think there's pros and cons of each.
Well, and so there's this novel concept, right? Use the monolithic where it makes sense. And if here's what I'm going to suggest. If there's an instance where you want to share a library that you're working on with another team or do collaborate, break that one library out until deliverable centric so you can collaborate. Because here's the secret. A lot of people are like, well, I don't want to let Dustin into our code base because I don't want him to see how horrible our code. I mean, I don't want to share our code with other people. So a lot of teams don't want to let people into their monolithic repositories because they think their either IP is too awesome or their code stinks so much they don't want people to see it. Or
both at the same time.
Yeah, or some variation of those, right? But it usually comes down to that.
Yeah.
So in those cases, just break off that one project into a deliverable centric and have both.
Yep.
Right? For some reason, years ago, they felt like we had to have one or the other. They couldn't have both. And so the solution is just use both.
Yep.
Use the tool as you need it, right? As designed. So we have a few of those.
Again, this past week, just talking about this because we have in one of our projects, we do have the delivery centric repository set up. So what we end up doing is we have, delivery A, delivery B, delivery C. And with this second project that we've now taken on, we are now seeing parts of the delivery, the deliverables from the deliverable centric project that we can go and reuse as part of.
Oh, that's awesome.
And the second project is a monolithic repo right now. So we can go and say, okay, well, we want to use the alert service, or, we want to use the notification service. Yeah. And those end up being the deliverables that we're able to use. And we can say, hey, we've got this code over here. It works pretty well. How can we make this, usable and share it with this other project or this other team?
Yeah, I find code reuse it causes the evolution of code, causes the evolution of our skills as developers. Usually it's not a copy. Well, never copy and paste reuse. That's really not code reuse. I won't rant forever, but that's a terrible pattern. Breaking it out and reusing, though, a lot of times what we find is when we have to reuse it, there's subtle changes to make it more reusable, more configurable.
And usually it makes it better.
Yeah, exactly. It makes it better. And it makes us better because now we're learning how to do that from the start.
Yep.
And so our design skills improve in that concept.
Yep.
So I won't rant forever about it.
Yeah, and again, hit us up if you guys got questions about the monolithic versus deliverable centric, because I think there's a huge debate on the internet as a whole, talking about the differences and pros and cons of all.
Well, it's clear this is the only way to do it. We are clearly the right way. We are clearly beyond debate, right?
Yeah.
No, and I'd like us to get to like some sort of terminology that's a little more common. I don't care what it is. I've chosen monolithic deliverable just because it's something people relate to.
Well, it also, if you talk in terms of like microservices too, that's not always the concept that people are used to. So if you try to like sub in microservice for deliverable centric, it just doesn't work. Deliverable centric ends up being a more broad term that can span multiple ideas and still drive that concept home.
I hear they're using the word macro service now.
That's just a monolithic repo. It's just a monolithic app.
We always swing to
fat app.
Yeah.
That's the term that the colloquial term we use is fat app.
Saying that.
Yeah,
it's like the marathons for anything over a 2-week sprint.
Yeah,
I can rant forever on that.
Yep.
One of my teams is currently doing 3-week sprints.
Yeah.
If you have a mid-sprint review, that's a sign of a problem.
Yes.
All right, so we're going to switch over to version numbering, right?
Yep.
So version numbering, right? So I put a little example up here. Typically, you're going to see like some sort of like 4-digit number. Okay.
So 4-digit numbers like this we refer to as semantic versioning.
Yeah, there you go. Perfect.
Yep.
So now, this first number 1, right? We all know what it is. It's called the major version number, and for me, this is the easiest one to describe. Okay. So and one of the things that we're going to talk about is backwards compatibility, right? And new features, right? All right, so when you do a major version release, so you're going from version 1 to version 2, there is no expectation of backwards compatibility. So I'm going to say no expectation, right?
Yep.
New features, there is yes and mind-blowing. Let me use that word, right?
Drastically different.
Yes. So like if you're going to go to a new version, and I will rant on my high horse, I love to use Apple or Mac as the example here. Early days of the iPhone, like they were doing mind-blowing changes every release, right? Not so much nowadays, right? I'm going to get all this hate mail. But
they're a little less.
But I think the early versions, Apple, when they did a lot of their products releases back in the Steve Jobs days, they did a great job of having major releases. Their announcements are huge, and it would do like really cool, mind-blowing new things, right? Like I always joked about like the iPhone like 12 would be something that would like, it'd be like a phone and a hoverboard in one, right? Because they were just changing things at such a rapid pace. And
cook your breakfast too.
Yeah, it's a really good example of a company that was evolving with these huge releases every release, right? And so I like to use that as an example. And there's no expectation for backwards compatibility. They changed the power plug at one point. That's okay, right? Like, as a consumer, that doesn't make me happy. I have to go buy $100 new cable. But like from an expectations management, that's what comes when you do a new version, right? So if we talk about 2 here, right? 2 is a minor version number.
Yep.
Now, get my handy dandy copy. paste. All right, so with a minor version number, what's our expectation of backwards compatibility? What does everybody think? As I erase this. Chat's kind of dead, guys.
Well, we got a lag.
Oh, there's a lag. Oh,
You got to remember the
All
lag.
right.
Yeah.
I'm impatient. Did you guys notice that ever? Right? Like the world's most impatient person. All right, so backwards compatibility, right? So typically when we're releasing a version like 2.1, 2.2, 1.1, 1.2, there is backwards compatibility is absolutely an expectation,
Yes.
right?
Yes, it is.
Nothing should change when I just do a simple upgrade, right? You know, it should have the same plugs. It should work the same. So there is a backwards compatibility expectation. New features for a minor version. Yes. Why am I getting it? If you're not doing anything better for me, why would I want it, right?
Yep.
So minor version number, there is an expectation for backwards compatibility and there is an expectation for new features, right?
Right.
So if we get to 3, now this is where we get into the debate. There's a little bit of debate on whether it's a bug fix or a build number. I'm gonna do the
Patch.
revision
or
number
Yeah.
versus build number.
Mm-hmm.
So the third number in some semantic organizations is really your revision number. And so a lot of times, let me get my handy dandy copy and paste here. So backwards compatibility, absolutely yes.
Yeah.
Okay. Now, usually there are not new features, it's bug fixes.
Yeah, or security patches.
And so we kind of referenced this. Remember when we did our little example in our paint diagram, we did 1.01. So if we're not getting new features, we're like security is a great example, right?
Yeah.
It's not a new feature to the user. Like it's not going to do anything new. You know, it's not. There's no new buttons. There's no new cool make me breakfast in the morning.
Yep, the app should function the same way it did previously, but
Except
better.
actually work.
But better. Yeah.
yeah. Like the bugs are fixed, or there's
Right.
the security hole. We're not giving away your data, like,
Right.
or we're not leaking something, right?
Yep.
So that's what the 1.01. Now, if a minor release can have new features and bug fixes, but if it has new features, then we roll all the bug fixes up and call it a minor release most of the time.
Yep.
Right? Now, if we go to the 4.0 number, a lot of times they were calling this a build number, right? So
Yep.
why was that important is a lot of times back in the day when we had like Solaris and different flavors of Linux, you would have to do a different build for each flavor of Linux. So you'd have to reference the build number. Oh, that was for Solaris. That was for HPUX. So a lot of times the build number is less meaningful these days.
Yep.
So like you saw us, we were doing 3-digit numbering there. So a lot of people have now switched to 3-digit numbering, or the 4th digit's always a 0. I feel like, you know, I'm kind of lazy. So if it's always going to be a 0, let's leave off the dot and the 0 and save 2 digits every time.
Completely agree.
So I think the build numbers kind of become less used. I'm going to say there's always an exception to rule. There's always a need for it, but in typical industry, we're not using it as much. Now, let's have a conversation here. Just like logging, the build numbering system is intentional. You have to stop and think about it. Right? I just had an argument with a team the other day. They did basically a major release and they called it 1.6. They literally changed the technology, right? That we were interfacing with them in Java and they changed the interface to JavaScript. And the interfaces weren't backwards compatible. They were completely different. Do you think that fits a minor release number from 1.5 to 1.6? No. And when I talked to their tech lead, he's like, yeah, you're right. I'm like, can you fix it? Well, you know, we automated our scripts. We just increment from 1.2 to 1.3 to 1.4 with the script every time. So the next release will be 1.7 because we just script it. Like, no, that's a fail because it doesn't communicate to us what's going on.
Right.
I know, like it's a life standard, not just a software standard, right? And I refer back to Apple. Like, you know, when you get those and everything else in life, if you start looking at when they do releases, you know, you have these expectations we've outlined here in life.
Yeah.
And like, you know, when I go to upgrade some app on my phone or my computer, if I see it's a minor release, I'm really quick to just, oh yeah, cool, it's fixing something. Just click it. Now, do I expect it to crash and not work anymore? No, right? I'm expecting it to be better.
Right.
Right. Our expectations have been managed. We've talked about managing expectations, that this is what happens. So as developers, we need to step back and make sure that we're implementing these common sense default practices in life, because the best thing that you can do in life are the things that are known, well understood, because there's little room for communication error if we follow the standard. If there's not a lot of standards in life, but if we follow the standard, right, we're clearly communicating. If I drive on the wrong side of the road, how do you think that's going to end? Pretty poorly, because we have this simple standard, right?
Yep.
And everybody follows it and it works. And if I don't follow the simple standard, right, I have horribly communicated with people and it usually ends very poorly, right? So follow these build numbering standards and think about it. Make it intentional. Oh, is this a minor release? Is it a bug feature? Like, follow those simple things, right? Make those simple intentional decisions, and your communication just is assumed, right?
Convention over configuration.
Yeah, and nobody can come back to you and say, Brian, it's not backwards compatible when you release 2.0. Like, yeah, no duh. Like, I got a Saturday class for you. Maybe you need to go to this class, right? Yeah, I mean, yeah. So those solve a lot of our problems that way. So that's our version numbering.
I was gonna say, and this extends beyond just developing services or developing applications. This is also used for libraries, frameworks that you're using. A good example that I find is Angular, the Angular JS library or framework, however you want to describe it. They have they follow this in that Angular 1 and Angular 2 are not compatible. You can't migrate and expect the code from Angular 1 to work in Angular 2. And so for Angular 4 even, they follow that, and that they are not backwards compatible. They are huge sweeping changes in fundamentals of how to use those frameworks.
Well, it's interesting, even to another real world example, I bought another wireless headset the other day.
Yeah.
And it's the newer version. It's a minor release version of the one I had before. And I was like, oh, wow, a lot of things were fixed. Like, it now syncs up easier. Like, when I switch, it works. Like, like
but
I
it's
thought
the same
it would.
Plug, right? It's the same plug?
No plug. That's the best part.
Well,
right?
yeah. It's the same interface.
Relatively the same interface, but the experience is better now. Right. And so I'm like, oh, wow. And then, like, we joke now when I walk over and get coffee, Julio can hear me now.
Yeah. Because before it was very crackly.
Yep. And so they fixed a lot of these different, and it gets rid of a lot of the background noise better now. Now he's not like, turn yourself on mute, the
blender's on.
Yeah. I think that'll still pick up.
Yeah,
but it does echo a lot of the background noise. So again, that's a very good example where my expectations were met. I bought a newer version and it just got better. Everything was the same, but it got better. Right. And so that worked. And I gave the other set to my kids. They stole it. So, all right. Any questions on version numbering? All right. I think
Very
I can
nice.
unshare my screen now. Perfect.
Let's see. Did we cover everything in the notes
Did we?
here? That's what I'm looking over just to make sure. Yeah, I think everything's covered in terms of the notes.
I think we're right on time.
A little over, but not
Well,
too bad.
we were a little late starting, so I'm going to grab I'm going to grab the time that we were late, and I'm going to steal it back. We're perfectly on time. Yes.
Were there any other questions in the chat today?
Yeah, if you have questions. I think.
Yep, I think that's correct, Matt. Yeah,
I don't know enough details about that.
Yeah, I
try to avoid.
I use Android, so I don't use Apple myself.
Oh, they switched me this year to Apple. Kicking and screaming, they pulled me over.
But interestingly enough, the one of the phones that I've used in the past, it's one of the Motorola phones. They upgraded the major version, and it was as if it was a minor version change. There wasn't much difference. So
yeah, I don't get new phones a lot.
I try not to.
Yeah. Scott and Julio forced me a new phone. Apparently, mine being all cracked up was a problem. The screen was cracked in multiple places. And then I couldn't load. Their thing was it wouldn't load Teams, and I couldn't be on a lot of their conference calls because my phone just wouldn't load it.
Sounds like success.
Yeah. I was like, oh, this is hey, I'm not complaining. The byproduct. So they went and bought me and they wanted me to be on the corporate Apple architecture, so they bought me the iPhone. So I will tell you, the swipes are all different. I'm learning it, but there was definitely a learning curve to it.
Yeah, not a problem. That's what we're here to do this morning. We're here to teach. We're here to spread our knowledge.
Yeah, and so with anything, I mean, provide us feedback. We're here to help. We always want feedback. We can make it better. Help pad out, like, and share all of our social media. We appreciate that. And, bring friends, send them the links to Exerceo, encourage others to attend. The best thing that we can do, we want more people to grow and learn. It doesn't hurt anybody else if we have more people coming and learning. Send links to the Rising Professional Challenge Series, the Rising Leaders Challenge Series. Our goal is to help society get better, help everybody learn, everybody grow, share our knowledge so that everybody else can grow. So if you extend that mission by doing the same thing, you'll find that you become a more of a focal point, and people will appreciate you for it. It will not push out opportunities for you. It'll probably extend your opportunities. So,
or grow new ones.
Yeah, it's always amazing. I believe in good karma, so good begets good. So go do wonderful things, and wonderful things will happen to you. Doesn't mean you will avoid bad luck. Look at those as opportunities to grow and learn. Honestly, as you get older and older, bad luck happens, and you just get better at shaking it off, right? It is an opportunity to learn to be a better person, right? And remember what I said is how you handle it, right? Just handle it with grace. When bad things happen, just handle it well. Be that positive sign for others. Be like, okay, all right, that was bad, but okay. How can we learn from it and approach it different? Problems are opportunities. We talk about that. So,
absolutely.
So go yonder. When do we meet next? I don't.
So Sammy did have another question.
Oh, go for it.
If bug fixes and minor improvements are made, is that an increment for revision number or the minor version number? So I think if we're talking
minor improvements, I'm reading minor enhancements.
Yes.
That's so as soon as the word enhancement comes in.
I'm thinking that's your minor version number at that point. If it was just bug fixes or the patches to currently working functions, then that would be your revision number.
I think the word enhancement is developer speak for...
I changed something.
Improvements. Right. So yes.
I changed something new.
Now it can't be a technical enhancement, right? I improved the build process is not a user enhancement. It's got to be an enhancement for your end users.
Right.
So yes, whoever your end user is. Yep. Any other questions, guys? Don't forget to do the
make sure you hit attendance.
Yep. And then we're meeting next on April 10th.
Yep.
So I'm excited for that. Is that next week already?
Yeah.
Wow. Man, this time flies by. And we'll work on getting started on time. We had some technical difficulties this morning. We were learning this morning.
Oh yeah.
And sharing our laughs together. Poor Pat was getting frustrated over there. We thought we were going to come live and see him banging on things, but we're all supportive. We can all laugh at each other together. And if you can't laugh, go look at my paint drawings this morning. We can all get a good laugh at my paint skills. There's room for improvement. I'm game for that. So thank you, everyone.